Sorry about that. Just wanted to quickly show you all that behavior before we jumped into it too much. So, okay, I'm playing the video again. All right, so this is wary. So you can see the robot's driving forward, and then as soon as it gets in the dark area, it stops. All right, okay, so let's go back to the document over here. All right, so the idea is if you look at this mapping right here, we see that when the light value is sufficiently high, and here I've marked out sort of the ambient light level of the room, sort of this hypothetical sort of level at which the light would be when we're not in a shadowy area. And as long as that value is over that, we would have a left and right wheel velocity of 0.5 meters per second. Let's just assume that's our maximum velocity. And then as soon as we start getting into this darker area, we're going to sort of drop down and eventually stop completely. Okay, that's probably pretty clear that that would result in that wary behavior. But to build a little bit of confidence, we can draw a few keyframes. So here we have the robot at some time instant where it's in full light, it's commanding left and right wheel velocities of 0.5 meters per second. Here it's actually entering into this darker region. The light levels are dropping, the velocities are also dropping. And then here we've gone completely into the darker area. So the left and right wheel velocities will be set to 0. Okay, so hopefully that makes sense. And we could see that we would, that would result in the robot sort of stopping in that area. All right, so now maybe we could think about one of the other ones. So going back to this video here, let's think of this indecisive one. All right, so we can see that the only difference there is that the robot, when it gets into the dark area, is actually going to want to sort of get out of the area, sort of reverse direction, and then it results in a sort of unstable equilibrium where it's kind of going back and forth, and it never quite reaches a point that it's sort of happy with. All right, so if we were going to program that using the same idea, we'll just kind of go here and let's just discuss what the result would be and how we would modify it. So here we have our graph of the light sensor measurement versus the velocity. So I think what we can see is that the only thing we would need to do is, instead of having this drop down to 0 as you get into a dark region, we want it to very quickly reverse direction. So we want this to drop precipitously and go all the way into the negative. So we might have it going 0.5 meters per second as long as the light value is above some threshold, and then drop down to negative 0.5 meters per second when it's below a threshold. And then what you'll find is that that would result in the robot sort of toggling back and forth between forward and backwards, depending on if it's on which side of the sort of lightness value of the sort of that threshold that it's at. So you can go ahead and do that and do a few keyframes and convince yourself that the robot would sort of move in and out of that dark region. Okay. All right, cool. All right, so the rest of this, we just have you going through all the different behaviors. Again, if you're, hopefully you can work through them on your own. If you have any questions on that, feel free to shoot us all an email or post on NV. We can take care of that. The second one asks you to think about, are there ones where, are there sort of behaviors where a sensory motor mapping in the strictest sense would not be sufficient to achieve them? So we're not thinking about the robot as having any kind of memory. We just have a direct mapping from sensor to actuator. So here again, we have light, which is a sensation. We can take that and go right to our velocity, all right? So one telltale sign that you need memory is if you think about, well, what would the sensory information the robot would be getting at two particular instants in time, but would have to execute a different motor command, all right? So it would have to go in a different direction or have a different velocity. So if we go back to obsessive at the beginning, let's make this one a little bit bigger. All right, what we see is that if we have the robot, kind of pause the robot right in the middle here, if we're just using the bump sensors, which we can imagine are just going to be either on or off depending on whether we are in contact with an object, When we're in this middle region, we're not going to know whether we're going sort of to the left to this shoe over here or to the right to that shoe over there. So in both of these instances that I paused it at, the robot has the exact same sensory information, but has to execute 2 different motor commands. All right, so if you were going to program the robot to execute this behavior, you would need some sort of basic memory to sort of keep track of which direction you're currently going. Are you going towards the shoe over here or the shoe over there? All right, so in this case, with a little bit of modification, you could just have some sort of flag that you kind of toggle back and forth depending on when your bump sensor makes contact with one of the shoes. So that would be a modification you could do to realize that behavior with one additional sort of bit of memory, if you will. All right, cool. All right, again, so that would be there. And then for those that are gonna actually go through this, we did create a template for y'all. So if you're interested in sort of using a similar workflow that we did to work through this Wary example, you can go ahead and use this. We designed this to be annotated in Zoom, so you can go ahead and do that if you like. All right, so hopefully that template will be useful. If you enjoy it, let us know. We'll make more things like this in the future. All right, this is just talking about the solution of how you would realize that behavior of obsessive. So here we talk about essentially how you would set the motor command based on the flag. So this either you have sensory information, like you're actually hitting something, in which case you know to sort of reverse course in the opposite direction, or stay or keep going in the direction you're currently traveling in. If not, and that would be, you could figure out that direction using this flag over here. Okay. All right, cool. All right, so that's it for the sort of Bratenberg vehicles. Hopefully that gave you a sense of what is possible with a pretty simple robot program. And we'll just be kind of going from there. Okay, so give me a second and I'll set up for the next part of the walkthrough.